Welcome to this explainer. Today we're diving straight into a totally groundbreaking project called ARGUS. It's essentially transforming these insanely complex scientific facilities into unified AI-native environments. Okay, let's get right into it, because we're looking at a fundamental shift here. We're talking about moving away from scattered, messy data and towards a deeply integrated, intelligent system for managing high-stakes scientific infrastructure.
To really appreciate this shift, you've kind of got to imagine the immense pressure operators face in a particle accelerator control room. I mean, they're tasked with controlling a machine that literally has thousands of highly sensitive, moving parts. Every single decision matters, and the sheer volume of data being generated every second, it's staggering. So what actually happens when we introduce a large language model, an AI, not to take over, but to sit right beside them as the ultimate co-pilot?
Well, right now, operators face this daily dragon, a chaotic fragmentation of knowledge. On one hand, you've got these static PDF manuals and technical docs. On the other, electronic logbooks, live Epic's control system data just continuously flowing in, and, perhaps most frustratingly, the tacit, undocumented experience that's just locked away in the minds of senior staff. When something goes wrong, an operator has to frantically try and connect the dots across all these isolated islands of information. It's a lot.
So these facilities might have literally thousands of operational signals blinking at any given moment, but they have zero unified knowledge. This hard separation between live operational data and structured historical knowledge, it creates a massive bottleneck. It severely limits quick diagnostics, it bogs down maintenance, and honestly, it just hinders the continuous improvement of the whole facility. You simply cannot optimize a system when half of its context is buried in some dusty PDF and the other half is scrolling across a live monitor. Enter the hero of our story, ARGUS. It's a secure, on-premise, AI-native knowledge operating system. The whole idea here is to give a large language model access to literally every single piece of knowledge that exists about a scientific facility. It's the bridge. It completely closes that gap between the static, boring documentation and the real-time, beating heartbeat of the machine. And the magic key behind all of this is what they call a unified knowledge layer. It sits perfectly right between the diverse data sources up top, like the logbooks, the manuals, the live data, and the AI model at the bottom. But here's the thing. ARGUS isn't just a basic chatbot. No way. It's a highly sophisticated hybrid system. It actually uses semantic search and knowledge graphs to draw relationships between historical records and then connects them directly to the live facility data. It actually reads the current state of the machine and understands it in the full context of the machine's entire history. Now you might be wondering, why not just use a commercial cloud AI? Why build this? Well, there's a critical hurdle. National scientific laboratories have incredibly strict data sovereignty and security rules. You absolutely cannot just send sensitive accelerator control data out to some public cloud server. So the absolutely crucial point here is that ARGUS runs securely on-premise using what are known as confidential containers. The AI operates entirely within the lab's secure network. Sensitive facility data never leaves the building. It's a truly sovereign, perfectly tailored AI solution.
Okay, Chapter 1, The Operator's Dilemma. Let's look at a real scenario. Imagine a late-night shift, right? An unexpected alarm triggers in the control room, and the operator needs immediate, accurate answers to prevent a massive shutdown.
Normally, when an anomaly hits at 3 a.m., it's panic time. We're talking scrambling through 5 different manuals or awkwardly waking up a senior engineer. But instead, the operator simply queries ARGUS. Because ARGUS is built right on that knowledge graph we talked about, it instantly cross-references the live alarm with decades of past incident reports and maintenance logs. The AI then suggests a highly specific corrective action based on exactly how a similar historical case was resolved. It's intelligent incident management that literally turns hours of stressful troubleshooting into seconds of action. Moving on to Chapter 2, the optimization spell. Let's see how this goes from just reactive troubleshooting into proactive facility optimization. This is where this unified framework really starts to flex the laboratory's capabilities.
So, operators often need to perform really complex tasks, like beam tuning. Instead of juggling a dozen different interfaces, the operator simply types a natural language request, just conversational text. ARGUS pulls the current live device data, and then the magic happens. Over the years, you see, different research groups have created specialized machine learning algorithms for beam optimization. ARGUS acts as a unified framework, instantly invoking those exact existing scripts. Finally, the AI presents the optimized parameters right back to the operator for confirmation. It's a true human-in-the-loop system. The AI proposes, the human approves.
Ultimately, ARGUS completely transforms these highly specialized, isolated domain tools. Previously, these were just artisanal, standalone scripts sitting on some specific server, probably only known to a handful of experts. ARGUS turns them into accessible, AI-callable services. Whether it's beam tuning or energy efficiency enhancements, literally any operator can now trigger these complex optimizations through simple, context-aware natural language. That is a game changer.
All right, Chapter 3, the software fix. Looking beyond just the physical hardware, what happens when the underlying scientific software itself starts acting up? Modern accelerators run on incredibly complex software stacks, and debugging them is notoriously difficult.
Well, just like it does with physical components, ARGUS integrates scientific software troubleshooting right into its unified framework. When a fault suddenly disrupts the standard control system architecture, or maybe a beamline physics simulation fails, ARGUS steps in. Rather than just spitting out some cryptic error code, it analyzes years of issue tracking histories, GitHub commits, and configuration records. From there, the AI acts as an expert software debugger, actively assisting the operator in diagnosing the root cause. It seamlessly unites the physical control room with the software engineering backend.
To really put this into perspective, think about the old way versus the new way. Searching for information used to mean hunting for exact keywords in hundreds of single PDFs. With ARGUS, you get contextual, semantic search. Incident resolution used to rely heavily on the personal memory and tacit experience of whoever just happened to be on shift that day. Now it's driven by intelligent retrieval via a knowledge graph. Operational tools used to be completely isolated. Now they are unified, AI-callable services. Ultimately, we are moving from a highly fragile system that depends on single experts to a robust, unified network of knowledge.
And that brings us to the core of it all. ARGUS isn't just about fixing machines a little faster or running a cool new algorithm. It's about generating democratized, traceable, and immediate knowledge across the entire facility. Because when expert knowledge is easily accessible to absolutely everyone in the control room, the entire laboratory operates at its absolute highest potential. As we wrap up this explainer, I really want to leave you with this thought to mull over. We've just seen how transforming isolated data into a unified AI-callable framework can absolutely revolutionize the control room of a particle accelerator. But honestly, this is just the beginning. If an AI co-pilot can master the chaotic, fragmented complexities of one of the most advanced machines on Earth, what other scientific frontiers are ready to be revolutionized next? Keep that in mind as we watch AI continue to evolve, not just as a helpful chatbot, but as a core operating system for human discovery. Thanks for hanging out with us, and I'll see you next time.